Welcome to Lesson 4, Introducing Langsmith, LangGraph, Fine-Tuning, and Edge AI. In this lesson, we will discuss how to leverage Langsmith and LangGraph, and we will go over examples of using fine-tuning frameworks and tools like Onslaught. We will briefly discuss high-performance computing and Edge AI, which is basically running AI models on edge devices. Let's get started. Now we're going to explore two powerful frameworks from the LangChain ecosystem. One is called Langsmith, and the other one is called LangGraph. Now, of course, this training is around building a lab, whether it's at home or in the cloud. These are applications that are optional. You don't have to actually have them in a lab environment, but these are very useful out there. Now, Langsmith is a comprehensive platform and is commercial, so you do have to pay for it. So if you're just getting started and you just want to do some evaluations and so on, you need to get the API key from LangChain in order to use this platform. But at the end of the day, it focuses on monitoring, debugging, and optimizing AI applications that are powered by the LangChain ecosystem and, of course, by large language models. So it provides you with the full visibility into the application that you're trying to create and your workflows, right? It has the ability for you to trace the prompts and the interactions between chatbots, agents, and so on with the LLM. So you can gain insights into every step of the AI pipeline from input to output. So in other words, from the prompt to the actual inference, so the output of the LLM. And you can also evaluate and compare different models, prompts, architectures, evaluate your system prompts, evaluate your retrieval augmented generation, deployments, and so on. And you can quickly iterate on prompts or configurations to achieve more accurate results. So that is actually Langsmith. Again, just a optional thing that you can play with, although you do have to pay attention to the cost. Now, LangGraph, that is another platform that is really comprehensive, that basically takes a little bit different approach than traditional AI applications by focusing on building stateful multi-agent workflows. So unlike traditional pipelines, basically LangGraph is trying to use or is using graph-based structures where agents act as nodes and their interactions form the edges of that node or that graph, if you will, right? So this LangGraph framework definitely excel at a few things. One is orchestrating complex workflows, so creating workflows with loops, branching logic, and conditional steps. Another one is state management, so maintain persistent states across interaction between your agentic implementations and, of course, your LLMs. And that it also enables memory and context awareness in different AI applications. And then you can also coordinate multiple agents. So nowadays we're living in a world where it's not about one AI agent, but it's a network of agents actually working together. So LangGraph can be used to build these sophisticated agent or agentic implementations, and that also handle multi-turn conversations while maintaining context to create an autonomous ecosystem to then collaborate on and produce the output for helping in complex tasks. Like, for example, you can do this for financial analysis, customer support, for healthcare. I mean, pretty much everything out there. So at the end of the day, this is something that you can deploy in the cloud. So there's a LangGraph cloud that is a commercial deployment, and you can also implement it locally. So you can download LangGraph Studio, which allows you to iterate through these implementations and, of course, create your agentic AI application. So for building something in a lab, I will recommend just to download LangGraph Studio first, become familiar with it, and then try to incorporate it within your environment. Again, the LangGraph Cloud is a commercial entity, so you have to pay for that. So start with LangGraph Studio in your PC, and then try to build, these sophisticated deployments and AI implementations. In this section, we're going to talk about fine-tuning AI models and what can you do in a lab environment. You already learned that many of the cloud platforms allow you to fine-tune models, and but we haven't even defined, what that is or explain how you can fine-tune models. Yes, even at home, especially with small language models like 5.3, 5.4, the plethora of them that they actually assist nowadays. But fine-tuning involves taking a pre-trained model and then adapting it to a specific domain or a task by training it further, and of course messing with the weights. And of course you need data in order for you to do that. For instance, you can fine-tune a model to be very domain specific, let's say cybersecurity, to be really good on threat intelligence reports or vulnerability assessment and so on, that they can help identify security risk, analyze logs, or suggest mitigation strategies for cybersecurity attacks. Now, what you're seeing in front of your screen is basically a high-level diagram of the fine-tuning process where you actually can select a domain. Again, I just mentioned cybersecurity. So after you select the domain, you incorporate a knowledge base. So in other words, your datasets, and then you select a specific task. In this case, of course, cybersecurity task. It can be also text summarization, creating code for specific, environments and so on. And then, of course, you have the task-oriented results, and you start evaluating the output of the model to then, either adjust some of the parameters and hyperparameters in order for the model to excel at a specific domain or at a specific task. There are a few different tools, especially tools that are open source, that allow you to simplify the process of fine-tuning. So I list a few examples of those, and of course, including the fine-tuning process as you see in there. I'm not going to go into the detail. However, if you keep scrolling down in the page, I have a few fine-tuning frameworks for language models, and specifically, I highlight 3 that are very popular. One that is called Onsloth, another one Axosloth, and then TorchTune as well. And hopefully I'm pronouncing those correctly. But by far, one of the most popular is Onsloth. It actually reduces RAM requirements and accelerates the fine-tuning process and supports different quantization techniques and different quantized models and quantization techniques like LoRa or QLoRa. And guess what? I also have another article in the same website, becomingahacker.org, about LoRa and QLoRa and quantization techniques and so on, but I'm not going to go into that in here. So as I mentioned, Onsloth is open source. It's available at the GitHub repository that you see in the screen. And you can also access an example Colab notebook that I do have a link in that write-up. And then, of course, that will bring you to this collaboration notebook. So Google Colab notebook. And in this case, it's an example of fine-tuning an older version of Llama, so Llama 3.1. And in this case, it can be applied to any other of the newer models, right? So you have examples here with Mistral, with Phi, and also there are the older models, but you get the point. Basically, this can be applied and can be used with many of the models that are available in Hugging Face. And it goes over pretty much the whole process from data preparation to training the model and evaluating the model as well. So definitely take advantage of that example. And as a matter of fact, even in the same write-up, I do have a couple of links to a few tutorials that also assist on the internet. Now, Axolot is another tool that is designed to provide this flexible environment for fine tuning, and it's also open source. And then the other one is a PyTorch native library called TorchTune. So there are, of course, a lot of cloud providers, and we covered that already. So Google Cloud, AWS, Azure, they have, Vertex AI on where you can fine-tune environments. SageMaker is another one, of course, from AWS and so on. So you learn about those platforms. I'm not going to cover them here again, but I wanted to give you some pointers of open source tools, especially powerful tools like Onslaught, TorchTune, and the rest. Even though this course is about building a lab, I would like to share with you at least a high-level overview of high-performance computing, what NVIDIA calls accelerated computing solutions, and also edge AI. So high-performance computing, or HPC, is basically the use of powerful computing systems, including GPUs, DPUs, of course, the integration of CPUs as well. Also, the implementation of ASICs, which of course is not represented here because NVIDIA, focuses on GPUs. But there are other companies like Grok, and this is not the AI model from X. It's actually a compute platform that specifically they design chips and create chips or ASICs that are tailored for AI implementations and AI models. So one of the differences between high performance computing and traditional computing is that unlike standard computers, high computing or high performance computing systems leverage parallel processing at a really, really large scale. So this one is not only for AI, it has been used for simulating weather patterns, designing safer cars through many simulations, and nowadays, of course, using AI. And tons and tons of industries actually use this, including manufacturing, healthcare, of course, all the providers of AI models or foundation models, including the OpenAIs, Anthropics, Googles of the world. Now, the other concept that I would like to introduce in here is edge AI and edge computing. And basically, edge AI combines artificial intelligence with edge computing to enable models to run directly on local devices. And again, we have been discussing that throughout the course here today. And they can also run at the network edge. So in other words, run in embedded devices like routers, like a Cisco router and so on, or even IoT implementations. So the other concept of this is running AI in autonomous vehicles, in robots, and many other implementations as well, and then bring in the physical AI applications. So in other words, be able to do a lot of the calculations in devices that can interact with humans, not only an autonomous vehicle, but as I mentioned to you, in a robotic type of implementation. So as we look to the future, the convergence of traditional computing, high-performance computing, accelerated computing, and edge AI will definitely continue to drive a lot of innovation, and this will unlock a lot of new opportunities in the field of autonomous systems, personalized medicine, and of course assistance in the form of robotic assistance, not only just a chatbot. And together, these technologies will definitely empower you to operate smarter and improve lives, hopefully. And we need to tackle the security challenges of that. And of course, I dedicated my whole life to cybersecurity, so I have to always keep cybersecurity and security of these systems in mind. But the future of computing is one where intelligence will be everywhere, whether it's in the cloud, at the edge, in your car, in your IoT systems, or probably very soon in a robot in your house, helping you with some of the mundane tasks and perhaps, listening to other courses like this one while a robot is actually performing the boring elements of cleaning and a lot of chores around the house.